Welcome to the NICER 201 online course on causal inference from observational studies. In this session, we will be continuing with our coverage on observational study designs. My colleague had earlier talked about classification of study designs. We learnt about the sequence of epidemiological studies as descriptive studies followed by analytical studies. Descriptive studies are meant to explore when very little is known about a given problem. Therefore, descriptive studies answer who, what, when and where regarding the given problem. It helps in generating ideas or hypotheses for associations between exposure and outcome. In contrast, the objective of analytical studies is to test the generated hypothesis or evaluate or determine an association using a valid comparison group. Therefore, analytical studies answer why and how aspects of a given problem. Case reports, case series, and cross-sectional study are certain types of descriptive studies involving study of individuals. Ecological study is a type of descriptive study involving measurement of exposure and outcomes at a group or population level. Type of analytical studies include case control and cohort studies. Experimental studies involving comparison groups are also analytical studies. Among these studies, cross-sectional studies are also called as prevalence studies can be used for descriptive or analytical purposes. When our objective is to describe or quantify or measure burden of a given problem or its risk factors or to generate ideas or hypotheses, we use the descriptive cross-sectional study. As an observational study, cross-sectional studies are limited by measurement of exposure and outcome simultaneously at a given point in time. Therefore, it has an inherent limitation of our inability to link exposure and outcome meaningfully and temporally. However, as we know from literature, cross-sectional studies can permit conclusions on associations between exposure and outcome when the nature of exposure studied do not change over time. Such exposure are referred to as unvarying exposure which do not change over time. The examples are blood groups, genetic markers and gender. Cross-sectional study design can also be used to evaluate or determine an association using valid comparison group. In this case, we call it as analytical cross-sectional study. In this session, we are going to see analytical cross-sectional study in terms of when we do and how we do and what we do. Many times, researchers use a cross-sectional study design with the primary objective to estimate the extent of a problem or burden or measure prevalence of risk factors. For example, estimate prevalence of hypertension in a community or measure prevalence of key risk factors for non-communicable diseases such as smoking, physical activity, etc. Furthermore, in some instances, investigators may be more interested in factors that affect the current burden of the disease or a problem in the given population. Hence, the investigators may set out to examine or evaluate or determine association of the exposures or risk factors studied with that of a particular outcome of interest. For example, to determine risk factors for hypertension as a secondary objective to that of the estimation of prevalence of hypertension. The presence or absence of risk factor or exposure of interest is compared between those identified to have had hypertension and those who do not have. This may be stated as a secondary objective. Sometimes, the primary objective of the analytical cross-sectional study may be to examine the association between risk factors and outcome of interest. As a measure of association in analytical studies, one may calculate prevalence ratio or prevalence odds ratio. However, according to the literature, prevalence odds ratio, both crude and the adjusted prevalence odds ratio, is a valid measure for few reasons. First, through prevalence odds ratio, we can estimate the incidence rate ratio with fewer assumptions than that are required for prevalence ratio. Prevalence odds ratio can be also estimated using the same methods as that of odds ratio in case control studies, for example, Mantel-Hansel method. Thirdly, it provides practical, analytical and theoretical consistency between the analysis of a cross-sectional study and that of prevalence case control analysis based on the same study population. Hence, in analytical cross-sectional studies, computation of prevalence odds ratio is considered as a standard method for analyzing prevalence studies and prevalence case control studies. You may refer to this example from an analytical cross-sectional study done by Yoganand and Bhatnagar. Their primary objective was to estimate prevalence of open defecation among adults having a household toilet. The sample size calculated was meant to answer this particular objective. In this study, they estimated prevalence of open defecation despite having a toilet in the household to be 55%. They also had a secondary objective to determine factors associated with the practice of open defecation in this setting. The analytical approach examined and evaluated a set of risk factors using a systematic approach of calculating crude odds ratio followed by adjusted odds ratio, and they also used a conceptual framework based on directed acyclic graphs. You may refer to the paper for methodological details for this analytical cross-sectional study. Ultimately, they compared those who practiced open defecation with that of those who did not practice open defecation and identified risk factors around socio-demographic characteristics, individuals' awareness, behaviors, perceptions, toilet design and water availability. They computed adjusted prevalence odds ratio for all of these identified risk factors. To sum up, cross-sectional studies can be used for analytical purpose of examining associations. Such analytical studies go beyond the traditional measurement of burden of a problem, especially for non-fatal conditions, and help in answering factors that affect the current burden of the problem in hand. In analytical cross-sectional studies, we compute prevalence odds ratios as a standard method. Thank you very much.